All right. Hi, everyone. Welcome to Phys 40B. I'm just going to be uh, going over what Lab 1's about and uh, just general stuff about it. So first off, the main point of the lab is to learn about buoyancy, or sort of when you place something in water, that object you placed in there is now going to experience some upward force due to the water that it's displacing. And so really quickly, the main four things we're going to be trying to get out of this lab are that you're going to be able to compare and contrast results that you found in the lab with expected values. And then if you find that what you expected didn't occur or you didn't get the values you expected, how to explain those discrepancies, like the physics behind those discrepancies. And then you're also going to talk about or learn about ways to alter an experiment in order to get the results that you're looking for. And so this is actually a big part of the lab because you're actually going to be designing your own procedure for this lab at one point. Okay, and then you're going to learn how to use some mathematical tools. Don't think this lab's going to include calculus, but if it does, you know how to do it, and I'll be able to help you do it if you get stuck at all. But you're going to be using scalars, vectors, and then pictorial representations like force diagrams to solve different problems. And then we're also going to learn how to explain an abstract model, or how an abstract model relates to physical phenomena, and then identify limitations of a model. So you may have learned last quarter in 40A or whenever you took 40A that one of the kinematic equations is x equals 1/2 AT squared plus V naught t. So this equation is assuming that this acceleration is constant, and then it also assumes that like there's no air resistance, and there's other assumptions, but those would be limitations of the model. Like it's limited to only being true under these ideal circumstances. And so really quickly, there's this introduction. Feel free to pause and read it. But the most important part is that this guy Archimedes came up with something called Archimedes' principle, which says that if you place some object in some fluid, the object is going to feel a lessening in its weight equal to the weight of the liquid that it's displacing. Okay? And then really quickly, the lab manual goes through this derivation of this equation for the buoyant force, but essentially it just says that there's some force on the top that's equal to this, and then there's some force on the bottom that's equal to this, and they just vary in this h1 and h2, which is these two heights. Okay, and then if we look at the object, we can see there's there's three forces acting on it. So if we want to find the net force in the object, we just add all three. And since the top and the gravitational force are pointing down, we're going to say they're negative. But the net force is equal to 0 in this case because the object isn't accelerating anymore. So net force equals ma, not accelerating equals m times 0 equals 0, right? And so we can define this F bottom minus F top as the buoyant force, or F sub b. Okay, and we'll see that this is equal to minus Fg equals 0, then just replacing this with F sub b, and then we'll find that the buoyant force is equal to F sub g, which is the mass of the water we're displacing times gravity. And we can see that actually matches here because this rho sub fluid is the mass of the water divided by the volume, and then we can then say that the buoyant force is the mass of the water divided by the volume times g times the volume. The volumes cancel, and the buoyant force is just equal to the mass of the water times g, which matches the equation up here. So that's nice to see. All right, so really quickly what the experimental apparatus is it's really simple for this lab. You're going to have a bucket of water, you're going to have various objects, and then you're going to have this force sensor that connects to capstone, I believe. And so you're just going to hang objects that have strings on them off of this hook, and that hook is going to pull down on this force sensor, and then you're going to unhook this, locking nut or whatever you call it. You're going to untwist it, and you're going to lower the object into the water, and you're going to look how the force changes over time. All right. And so now to actually get into what the lab's going to be. So in the first part of the lab, you're just going to draw force diagrams for these 4 separate cases. Feel free to pause and read them. And once you draw those force diagrams, you're going to think about, how they differ from each other. Are they the same? Are some aspects of them the same? And then you're going to set up the Newton's second law equations, which is just the sum of all forces equals ma net. And then in this case, the object is not moving, and even more so, it's not accelerating. So this is going to be equal to 0. All right. And then you're going to try to use what you learned in 1.1 and 1.2 to solve this, or not solve for this, to show that this equation of equality is true. And then the second part of the lab, you're going to have these 6 objects, and they have similar properties. A lot of them have similar properties. And so what you're going to be doing is you're going to be designing an experiment or procedure that answers these 4 questions. So feel free to pause and read those 4 questions. It's going to answer these 4 questions. And these 4 questions are essentially just saying, like, if objects have the same volume, do you find that the buoyant force is the same for all of them? If they have the same mass, is the buoyant force the same for all of them? Does it differ? Are there similarities? So you're designing a procedure or an experiment that answers those questions. And so you're essentially going to be testing Archimedes' principle, which says that the amount of the mass, or the weight, not the mass, the weight of water that you displace results in a lessening in the weight of the object, the weight that the object feels that it is by a certain amount. And then the last part is you're going to look at these thought experiments. So this first one is just saying, if I take 2 objects and I put them in this water, if I put the object in the center, does it experience the same force as the object in the corner? The second one is that you have some meteorite, you find that it has some weight, and then you place it in water, and now you find that the weight is less, and you're just going to be trying to calculate the density and stuff related to the meteorite. And then the last one says that if you have a boat and it's in water, and I have some piece of iron in the boat, the amount of water that's displaced due to the iron being in the boat, is that equal to, less than, more than the amount of water that would be displaced if I had the boat like this, and then I just threw the iron into the water? So is it the same? Is it different? You're going to be thinking about that. So that's going to be the entire lab. I'm going to try to keep these a little shorter in the future. As the first one, so it took me a little longer than I might have hoped, but time permitting, I will try to make these for all the labs. I think it'll be helpful just to give you a good idea what the lab is before the lab, but I'm excited to take for this class this quarter, and I'll see you soon.